Hello everyone. Today I'm going to demonstrate and show you guys the system that I have developed and built using the PIC24 FV16KM202 microcontroller. The system consists of the PIC24 itself and a RN42 Bluetooth module and a C# GUI application that's developed using Visual Studio Windows Form. What the PIC24 is doing is that it is implementing a digital filter. So it acts as a filter engine. Uh, Different filters can be loaded to PIC24, and PIC24 will be digitizing or say sampling a input signal and filter that signal accordingly. So in this case, I'm using a wave generator to generate a square wave signal, and PIC24 will try to extract certain harmonics of that square wave signal. And so we know that square wave signal have an infinite number of harmonics, odd harmonics, and so PIC24 will try to extract certain harmonics from the square wave signal. So the Bluetooth module again act as a communication pipeline between the PIC24 and the C# GUI application that's running on my laptop. And so let's first start by connecting to our Bluetooth module. So connection is successful. Okay, there we go. By default, the system starts up with using a low-pass filter with a cutoff frequency at 100 Hz and sampling frequency of 2 kHz. So here is the red waveform is the sampled square wave signal, and the blue waveform is the outputted signal, which is a sine wave signal. And so the input signal is a square wave signal with a frequency of 100 Hz. And here is the frequency spectrum of both the input signal and filtered signal. We clearly can see that the red signal is the input signal because it have many harmonics, and after filtering using our low-pass filter, digital low-pass filter, we see that there exists only one harmonics, while all the other harmonics got attenuated to a certain level. And the next harmonics to the blue waveform here is the third harmonics, which center at 100 Hz, at 300 Hz, and it get attenuated to roughly about minus 42 dB or so, which is really good. And it demonstrated the purpose of this project. So down here we have different buttons and text box that the user can look at and control the system, and as well as selecting sampling frequency and the different filters that we have available for us. So 6 filter in total, 3 low pass filter and 3 band pass filter. So let's pick a different filter. Let's pick a band pass filter that have a center frequency at 300 Hz with a sampling frequency of 2 kHz. So let's see what happened when I click here. When I click this filter, what should happen is that it should start to load the coefficient. So load a new filter to the PIC24, and we should see that it's extracting the third harmonics, which is which we should only see the 300 hertz content at the output. There we go. So we clearly see that it's working properly. So here we see that it no longer extracts the first harmonic, but now it's extracting the third harmonics while attenuating all the other harmonics. And here is the time domain frequency. The time domain signal. Here is the signal itself, the input signal, and here is the output signal. So higher frequency now, and we have our resolution is not as good, but the system is doing its job, and we can also zoom in to look at to get a better look at the signal at the output of the filter. And so here this C# GUI application also incorporated a very cool features, which makes it very nice for the user and very unique as a project itself. So the user can design the filter in real time using the Window-sinc filter designer method, which I got it from a book. This book, it's a very nice book. I love this book. I've been reading it over the summer. It's called The Scientist and Engineer's Guide to Digital Signal Processing by Stephen W. Smith. I highly recommend this book. So I grabbed some knowledge from this book, which I also included in my report, which section exactly that I utilized it and borrowed it from. And so here the user can design different filters such as band pass, low pass, high pass. So 3 different filters. Band reject is not being implemented, but for this project, band pass and low pass filter is what's being used it. And so the user have the control of selecting the different window method to be used it, such as Blackman, Hamming, and Henning. User can also input different order number, sampling frequency, cutoff frequency. And so this first cutoff frequency input is only used for low pass filter and high pass filter, which in this case we will not be using high pass filter, only low pass filter. And for band pass filter, these 2 input down here will applied. Since band pass filter have a center frequency, so we need 2 cutoff frequency to define it, since we are using the window method. So here, let me demonstrate it by designing a low pass filter with a sampling frequency at 2 kilohertz and cutoff frequency at 100 hertz with 64 taps and using the Blackman window. So here is the performance of the low pass filter that was designed using this filter designer tool. So here in the middle we see the coefficient that's being generated, and to the right we see the window that's being used it, and as well as the sync function. So these 2 convolved it together, and the frequency domain produces this. Convolve these 2 in the time domain, in the time domain. Convolve these 2 in the time domain, and we will produce this if we looked at it in the frequency domain. So here we can pick different, let me zoom out, we can pick different window and see the performance of it. So here is the Hemming, and here's the Henning. I like the black man and the Henning, since they have very good attenuation. So here we know that if we were to extract the first harmonic, which is the 100, which is at 100 hertz, it will have a half power reduction, right? In term of power, be 3 minus 3 dB. But if we look at amplitude, then it would be minus 6 dB at the 100 hertz. So here at 100 hertz, it's at minus 6 dB. So this is good, and we know that the next harmonics is at the third harmonic, which is at the 100 hertz. So at the 100 hertz, we can conclude that it get attenuated to roughly minus 80 dB. And so we can load this low pass filter in real time to PIC24. And how do I do that is that now that I have designed it, all I have to do is just click this load button, and it will load that filter, and we will see it in action. Let me do that. There we go. So now instead of extracting the third harmonics, it's now extracting the first harmonics. And so our DFT, since we're implementing the DFT to get these two frequency spectrum, we can perform a search to get the peak, which at the peak we can look at the frequency, and so our algorithm determines that the filtered signal have a frequency at a frequency of 101 hertz, so close enough to the 100 hertz signal. So now let's go back to extracting the third harmonics by using one of our predefined filters that we used earlier. There we go. So here is using the pre-designed filter to extract the third harmonics. Now let's go back to the one of the pre-designed filter, which cannot be changed or altered because it's already predefined and hard coded. So let's extract the 100 hertz, so the first harmonics. Let's wait. Okay, there we go. So the 100, it's extracting the 100 hertz signal, which is the first harmonic. Now let's try to use a low pass filter with a cutoff frequency at 50 hertz and sampling frequency of 101 kilohertz. So I change it to 1K. Now the filtered signal is very messed up because we have to change this to 50 hertz. So now let's reinitialize the output of the filter. There we go. So 50 hertz. And let's design a filter, a bandpass filter that will extract the third harmonics. So the third harmonics of the 50 hertz input is centered at 150. So 145 and 155. There we go. Let's use the black man window. There The attenuation is a lot better. Now let's load this filter to extract the sampling frequency is 1 kilohertz. There we go. Now let's load it, and hopefully we're able to extract the third harmonics, and I think we will be able to do so. There we go. We're now extracting the third harmonics, and the filter that we're using is generated using our filter designer tool, using the Window-sinc filter designer tool method that I have embedded in this GUI application. So this is the demonstration of this project. Thank you for watching.